Wide camera. The wide camera is the main lens found on almost every smartphone, and it handles most everyday photography. It usually has the largest sensor and the best image quality among all cameras on the device. Manufacturers design it to capture scenes similar to how human eyes naturally see the world. Because it gathers more light, it performs better indoors and at night, making it the default choice for portraits, landscapes, and casual photos. Ultra-wide camera. The ultra-wide camera expands the field of view far beyond the main lens, allowing more of the scene to fit into a single frame. It became popular as smartphones replaced traditional travel cameras, especially for group photos and architecture. The lens bends light more aggressively, which can create slight edge distortion, but the advantage is dramatic perspective and spacious composition that feels immersive. Telephoto camera. The telephoto camera is designed for optical zoom without physically moving closer to the subject. Instead of enlarging an image digitally, it uses a longer focal length to preserve detail. This camera is commonly used for portraits, wildlife shots, and distant subjects like buildings or stage performances. It produces more natural background compression, which helps subjects stand out clearly from their surroundings. Periscope camera. The periscope camera uses a folded lens system that redirects light sideways inside the phone using mirrors or prisms. This clever engineering allows smartphones to achieve powerful zoom levels without making the device thicker. Originally inspired by submarine optics, the design enables long-range photography, such as moonshots or distant landmarks, while maintaining reasonable image clarity. Macro camera. The macro camera specializes in extreme close-up photography. It allows the lens to focus at very short distances, revealing textures invisible to the naked eye, such as fabric fibers, insects, or tiny details on everyday objects. Early smartphone macro cameras were simple additions, but newer versions combine higher resolution sensors with autofocus to create sharper and more usable close-range images. Depth sensor camera. The depth sensor camera does not primarily capture photos on its own. Instead, it measures distance between the subject and the background to create accurate depth maps. This information helps the phone simulate background blur, known as portrait mode. By understanding spatial separation, the camera can isolate faces or objects more convincingly, improving realism compared to software-only blur effects. Time of flight camera. The time of flight camera works by emitting invisible infrared light and measuring how long it takes to bounce back from objects. This technology provides extremely precise distance measurement and improves augmented reality applications, autofocus speed, and low-light portrait photography. It represents the shift of smartphone cameras from simple image capture towards spatial sensing devices. Monochrome camera. The monochrome camera captures images without color filters, recording only light intensity and contrast. Without color processing, more light reaches the sensor, resulting in sharper detail and improved low-light performance. Some smartphones combine data from monochrome and color cameras to enhance overall image quality, while others use it purely for artistic black and white photography. Front or selfie camera. The front camera is positioned above the display and is designed for self-portraits and video communication. Its development closely followed the rise of social media and video calling. Modern selfie cameras often include wide lenses for group shots, beauty processing options, and advanced autofocus systems to keep faces sharp during movement. Under-display camera. The under-display camera sits hidden beneath the screen, allowing uninterrupted displays without notches or punch holes. The display becomes partially transparent when the camera activates, letting light pass through to the sensor. Although image quality currently trails traditional selfie cameras, the technology represents a balance between immersive design and functional photography. AI computational camera. The AI computational camera is less about hardware and more about software intelligence working behind the scenes. Smartphones capture multiple images instantly and merge them using algorithms that adjust exposure, color, sharpness, and dynamic range. This approach transformed smartphone photography by allowing smaller sensors to compete with larger traditional cameras through advanced processing rather than optics alone. Night mode camera system. The night mode camera system combines sensor sensitivity, stabilization, and computational photography to capture clear images in extremely low light. Instead of a single exposure, the phone records several frames over a short period and blends them together to reduce noise while preserving detail. This and AI noise